Welcome to LJ Institute of Engineering and Technology in the Department of Instrumentation and Control Engineering. In this session, we have to discuss the subject that is Instrumentation in Agriculture and Food Processing. I am your instructor, Jayesh Prajapati. Now, in this session, we have to discuss the chapter number 4, that is Water Distribution and Management and Control. Okay, so in this chapter we have to discuss the content that is irrigation canal management. So that is the content that we have to study, irrigation canal management, then water distribution and management control. Then we have to discuss the content that is auto deep irrigation system, and the last that is application of SCADA for dam parameters and control. So that is a theory content that we have to study in this chapter. So let us start with the first topic of irrigation canal management. So we know that the irrigation system, that means we have to supply the water to our crop or plant. So let us see the definition for irrigation system. The irrigation system is the system that having a process of supplying the water to crop plant growing in the field by means of canal, reservoir, well, tube wells, etc. So the irrigation, that means we have to supply the water to the crop or plant. Then we can say that the water provide essential micronutrient to the crop, that is hydrogen and oxygen, that we already know that is H2O. So that is the irrigation system. Then we can say that the irrigation system consists the following. Now we have to manage the irrigation system. That means we have to water distribution management. So here we have to divide this irrigation system into a different parts, and each part is work as a management. So let us see the irrigation system having a following. That is, first, that is a main intake structure and main pumping station. Then second, that is a conveyance system. That means we have to convey this water from main tank to the distribution system. Then that is the distribution system. Then a field application system. A field application system, that means our crop or plant or our farm, that is a field that we have required the water for irrigation purpose. Then the last, that is a drainage system. So that is a drainage, that means we have to drain the water, the excess of water that is not required by the plant or crop, that we have to drain back to our main intake structure. So that is a irrigation system, different part. Here there are 5 different blocks. Okay, main intake structure and pumping station, then conveyance system, distribution system, field application system, and drainage system. So there are 5 blocks, okay, for irrigation system. Now we have to discuss each block one by one. Before we have discussed this, first of all, you can see the picture of irrigation, that is the picture of irrigation system. So here you can see, here that is a main intake system. Okay, from this main intake system, that is means a river or reservoir. Okay, then we have to pump by using motor or pump, like a centrifugal pump. By using pumping station, it can be distributed or conveyed to the different conveying system. Then by using this conveyance system, the water is distributed in different field application system. So here you can see the field application system, and by using the field application system, the remaining of water, the excess of water, that is drained back to this our main intake system. Okay, so that is the main picture of irrigation system that we will try to explain how irrigation management has been done. Now, the next, the first block, that is a main intake structure. So in the main intake structure is built up at the entry to the irrigation system. So that is the main intake structure. Then its purpose is to direct water from original source of supply like a lake, river, reservoir into the irrigation system. So that we already know. So if we see the picture for main intake structure, then it's look like this. You can see there is a one river in the one village. Okay, so here from this river we can take water in storage tank like a reservoir. Okay, so that is the main intake structure. Now the next, that is a pumping station. So pumping station why required? So in some cases the irrigation water source lies below the level of irrigated field. Then a pump must be used to supply water to the irrigation system. So we know that a pump or a motor can be used to supply water from lower level to the higher level. So here sometimes we can use a pumping station also, okay, to supply water to different irrigation field. Then there are several types of pumps, but most commonly used the irrigation, that is a centrifugal pump. So now we can see the feature for the pumping station. Then the pumping station feature is like this. You can see one of the river in the village. Now we have village water is collected by using pumping station and it will be distributed to this irrigation system. So that is a feature for pumping station. We will try to explain better way, so that's why we can use a different kind of pictures that can understand very well how it can be work. Okay, so that's why we can use this kind of pictures. Then a conveyance and a distribution system. Conveyance and distribution system, that is a main part of this irrigation management, because we have to collect this water in reservoir, river, then we have pumping station. Now we have to distribute this water to different areas or different farms or different field applications. So we have to manage, then that means we have to convey this water and we have to distribute this water, and also we have charge for the farmers for the use of water. So that's why we have also measurement and control of water. How we can control the flow, how measure the flow. So that is a main important topic for this irrigation management. So that is a conveyance and distribution system. So let us see. This system consists of canal transporting the water through the wall irrigation system. The canal structures are required for control and measurement of water flow. So in the conveyance and distribution system, we can use a canal system that we already know to supply different farms or any irrigation field. We have to use a canal. So first of all, that is a open canal that we already seen in sometimes when we visit some farms, that open canals are available. So you can see an open canal is also called as a channel or ditch, is an open waterway whose purpose is to carry water from one place to another. Channels and canals refers to main waterway supplying water to one or more farms. Field which have a smaller dimension and convey water from farm entrance to the irrigated fields. So that's why we can use open canals to supply water. Now, canal having a different kind of characteristics as per its construction and design. So there are different types of design consideration. Let us see. According to the shape of their cross section, the canals can be called as a rectangular canal, then triangular, then trapezoidal, and then circular, then parabolic, and last, that is irregular or natural canals, that by natural it can be happen. So that are the different canal characteristics that is available as per the design or as per the cross sectional area. So that are the conveyance and distribution system. So here, that is in canal characteristics. If we see the one of the example or one of the figure for canal characteristics, then you can see a trapezoidal canal cross section. So the most commonly used canal cross section, irrigation and drainage, that is a trapezoidal cross sectional. So you can see that is a picture for a trapezoidal canal concentration cross section. So in this figure you can see the depth, okay, the depth of canal A, top width of the canal, that is A. Then A1, that is top width of water level. Then H, that is the height of the canal. You can see that is the height of the canal H, and H1, that is the height of water level. And B, that is the bottom width of the canal. You can see the B in this here, that is the bottom width of the canal. And H and W, that is a slight slope of the canal. Okay, for GTU or MCQ purpose, if you have asked the MCQ related to this cross section, that means some canny theory is used to have a better length and width. Okay, that means slope H and W is in equal ratio. That is a good design consideration for canal management. So H and W is very ratio is very important. Then F, that is a freeboard. You can see F, water level and the canal, the freeboard space, that is F is equal to H minus H1. So that is a design consideration for trapezoidal canal cross section. In this way you can design rectangular, triangular, circular. Okay, so that is a different canal cross section that is used for conveyance system. Now we have to discuss the distribution control structure. In the conveyance system that we have discussed, that is by using canal. Now we have to distribute this water into the different irrigation field system. So that is a distribution control structure. Distribution control structures are required for easy and accurate water distribution within the irrigation system on the farm. So we have to distribute this water in very as per requirement. So we can use a distribution boxes. Okay, because once way water is distributed in one farm, two farm and three farm, but farm number 3 is not required at that time. So we have to control this water flow by using division boxes. So that is one of the type that we have to control this water flow. So division boxes are used to divide or direct the flow of water between the two or more canal or ditch. Water enter the box through the opening of one side and flow out through the opening on other side. These openings are equipped by the gates. So the related pictures for the distribution box you can see. Okay, in this figure you can see one arrow that is shown here. So this arrow, that means a water. Okay, and here some hanging type gates. Okay, 3 gates are here. So that is one 4 cross section. So here in this 3 are the water distribute required. So here first, that is the inlet water. So gate 2 gate will be open by using distribution box. You can see gate. Okay, and one gate is closed. So in this way we can control the water flow to this different irrigation field. Okay, that is the one types that we can control by using division boxes. Now in the next you can control this by using turnouts. Okay, so the turnouts are constructed in the bank of canal. They divert the part of water from the canal to the smaller one. So if we see the picture for this, then you can see that is a concrete turnout. So here you can see that is a concrete canal that can that means it can reduce the water flow and it will be turned out as per our requirement. They can divert the canal flow. So that is one of the another way to control the water flow. Then the next, that is a check. The next to control the distribution control structure, that is a check. To divert water from the field ditch to the field, it is often necessary to raise the water level in the ditch. Okay, the checks are structure placed across the ditch to block temporary and rise the upstream water level. Checks can be a permanent structure. So if we see the picture for the checks, then you can see we have to block, okay, this triangle type of check that can be used. So that can be blocked for water for sometimes, that means water level in upstream type, okay. Sometimes different types of checks are also used that having a blank space at the bottom side, okay. So that is having a blank side on upper side, so that can control a upstream water level, and if bottom side, then it can control a downstream water level. So that is one of the other distribution control structure, that is a check to control the water at the upstream level, okay. Now crossing structure. Some crossing structures are used. It is often necessary to carry irrigation water across the road, hillside and natural depressions. Okay, so crossing structures such as flumes, culverts and inverted Simpson. Okay, so this kind of crossing structures can be used. So here you can see first, that is a flume. Flumes are used to carry irrigation water across gullies, ravines or other natural depression. They are often canal made of wood, bamboos, metal or concrete, which often need to be supporting by pillars. So sometimes water can be controlled by using this kind of crossing structures. So here is the picture for the flumes. You can see that is a triangular types construction. So if we see the live picture, that so better idea. Okay, so that is one kind of flume pictures from naturally we have taken. So here you can see a concrete flume. Okay, that is concrete flume, but you can also made by metals or also by bamboos woods. So flumes will be made. So that kind of crossing structure that can be used for irrigation water at if it is on roadside or if mountain. And so if we have to divert it by, okay, if we have to supply better rate, that times we have underground, so that times we can use this kind of crossing structures. Okay, now another, that is a culvert. So culvert are used to carry the water across the road, and the structure consists of concrete headwills at the inlet and outlet concentrated by buried pipelines. So culverts is like this, you can see. So this kind of picture we already saw, that is some pipeline. By using some pipeline, water can be flow in underground station also. So that's why if railway is railway is going to this way, then we have to use this kind of culverts system also. Okay. Then next, that is inverted Simpson. So that is the most important crossing structure. So when water has been carried across the road, which is at the same level as below the canal bottom, an inverted Simpson is used instead of culvert. This structure consists of inlet and outlet concentrated by pipeline. Inverted Simpson are also used to carry water across a wide depression. So sometimes we know that whenever water is flow in very large area, so like big pillars, okay, can be used, and that is also called as an inverted Simpson. Inverted Simpson having different kind of design also. If some railway or if another construction is available, then we have to divert in downward side also. So that means we have inverted Simpsons can be used. So if we see the pictures for this, then you can see that is an inverted Simpson. So here you can see inlet and outlet two pipes are also, and also at the water road level the canal is going, so we can use the construction like a inverted Simpson. So that is the picture for inverted Simpson. That is the most important crossing structure in this topic. Then water measurement. If we have to measure the our water level, because we know that in the irrigation scheme where water costs are charged to the farmer, water measurement provides a basics for estimating water charges. So that's why water measurement structure is most important. Then if if we have to measure this water, then different techniques will be used. So first, that is a weirs. Weirs, that is a simplest form, consists of wall of timber, metal or concrete, which is opening with fixed dimension out in its edge. The opening or closed notch may be rectangular, trapezoidal or triangular. So this figure is like this. You can see that is a rectangular weirs. So here you can see we can connect flow meters that can measure the flow, or levels, or level sensor that can measure the water level and flow. Okay, so here we can use a rectangular notch. Okay, so that can measure by using rectangular wires. Then here we can use a triangular weirs. So that kind of different techniques that can be used to measure the water level, and also a trapezoidal is also used for the thing. Then water measurement by partial flumes consists of a metal or concrete channel structure which have a three main station, that is a convergence session at the upstream, then a constricted or trot session, and the last, that is a divergent session at the downstream end. So here this three structure will be used. So here in first, that is a inlet, then second, that is a measuring station, and then third, that is a diverging, that is downward stream end. So if you see the picture for this, then you can see here first, that is a convergence station at the upstream. We can enter the water inside. Then at the trot station we have a measuring scale, so water will be measured. Then the diverging station, that means downward side end. So that is another method to water measurement. Then field application system. So here in the field application, that means our farm or our areas or our crop or plant. So we have to water available at the field application system. So now we have to distribute, or we have to give a water to our crop or plant. So that is our field application. So there are different kind of techniques for supplying the water to our crop. That is a surface irrigation, then sprinkle irrigation, then crop deep irrigation. So that are the different irrigation systems that can be used here in field application system. Now first, that is the surface irrigation. So here you can see in the surface irrigation is an application of water to the field at ground level. So ground level, if we have to supply the water to our crops, that's why we can use a surface irrigation system. So here in this picture you can see the water level is on high. So we have like a reservoir and the crop having some kind of spacing. So that is called as a furrow irrigation. Furrows are narrow ditch dug on the field between the rows of crops. Here the rows of crop. Okay, in this row we have used a ditch. Okay, and the water runs along them as a move down to the slope of the field. So that means water will be supplied by using furrow irrigation system. So a furrow irrigation system is a types of surface irrigation system. Okay, the main type, that is a surface irrigation system. Now in the furrow irrigation system we have also another way to supply water, that is by using small pipes. So in this figure you can see here a small pipes are connected. Okay, that is called as a splice or small pipe buried in the ditch bank. So that can supply water to this row of the crop. Then another way to supply this water by flexible pipes. So here we can use the use of splice or siphons, are small curved pipes that deliver water over the ditch bank. So that is another way to supply the water to our crop. So that is a types of furrow irrigation, and furrow irrigation, that is a type of surface irrigation. Now in the field irrigation system, field application system, we have to next, that is a sprinkle irrigation system. So in the sprinkle irrigation system we already know that we can use a sprinkle. So here we can supply water to our crop as per by using automated system. Okay, and also this having a saving in water also, because in the traditional system there is some kind of water will be waste, but here in this way we can control the water or we can save the water. Now the next, that is a deep irrigation system. So in the deep irrigation system, if you see the picture for the deep irrigation, then you can see the dot, okay, the deep small drop of the water is going to the depth of this crop, and it will be a saving of water, that is direct water is given to this crop base. So that is a picture, that is another pictures of for deep irrigation system. You can see in the picture different lines are connected in long way. It can be used a deep irrigation system. Okay. Now we know that there are different types of irrigation system. So soil based irrigation system, as per the soil, we know that crop ground in sandy soil require more frequent irrigation than crop down in clay soil. Means dark soil require less irrigation, but sandy soil require more irrigation. That is a soil based irrigation system. And another way we can say that crop based irrigation. So as per our crop like wheat, gram, cotton, that require more water supply than other crop requirement. So as per the crop or product require, as per crop require, we have used a different kind of irrigation system. Now we know that in a traditional method we can use a moat or pulley system, then chain pump system, then Dalki system, then Rahat or level system. That are the old system that can be used for irrigation. So let us see this. First of all, that is a moat system. So in this picture you can see that is a manually giving a water to our crop or plant. So that is a time consuming and saving water is waste in this year. Then chain pump system. So here you can see by using manually chain pump, okay, by using chain roller, then buckets of water buckets can be filled by the water and it is collected on upward side. So that is another old traditional system. That is another picture same to the chain pump. Okay, that is an old system that can be replaced with modern system. But we have seen so how the water irrigation is in past available. Here in the Rahat system, we have not a water pump. Okay, cost of water pump is high, so that's why we can use animals to supply water to this our plant or crop. So that's why by using animal we can use water supply. Then Dalki system, so that is a pictures of Dalki system. Then we can use manually to supply water by using Dalki system. Okay. So that are the different techniques that can be a traditional old system. Now the modern method, we know that sprinkle irrigation and deep irrigations are example of modern irrigation system, and its method help in saving of water. So we know that deep irrigation system, that is a picture for deep irrigation that we already discussed, and that is a sprinkle irrigation system. In this sprinkle irrigation you can see that is a picture. So that are the modern techniques of deep irrigation and sprinkle irrigation system that are already available here also. So now we have to make a auto deep irrigation. How we can make our system to auto? So that's why we have required a general block diagram of auto deep irrigation system. So you can see we can use Arduino here, ARN7, that is Arduino board, or we can also use microcontroller. Here we can use a signal conditioning. Okay, in signal we have temperature sensor, humidity sensor, soil moisture sensor, pH sensor, and then keyboard. Okay. Then on the back side you can see the one LED display for displaying how which parameter is measured. Then RS232 communication channel can be connected to the PCs, and this Arduino is a driver to this water storage. Okay, and here there is a one solenoid valve is also used to connect this to the our different farm. So that is the auto deep irrigation system that can be used. Then the basic structure of irrigation control system, if we have seen, then that is first, that is a irrigation controller, that means a programmable device, analog interface, then analog to digital converter communication line that is required. Then different kind of water determination it can also require, like soil sensing, plant sensing, okay, water balance. Then water supply by using filters, by using pressures and water meter, okay. Then boiling pumps by using electric generator or by diesel or kerosene. Then irrigation execution by timers, flow meter, solenoid bar, transducer, chemical use, fertilizer. So that are the different parts that can require irrigation control system. So now if we have to make automated irrigation system, then that is a picture for automated irrigation system. So here in this picture you can see there are 6 farms, there are 8 farms are here, and in every farm you can see a solenoid valve is given, okay, on the black line, and yellow, that is a main solenoid valve from the main intake system, and every farm having a sensors that can be detected by the interfacing unit, and it can measure the different like temperature, moisture, water available. So by using this automation, it is communicated by these our PCs, okay. So that is a fully automated irrigation system. If we have to make automated irrigation system, then we have to design like this. And you can see also a solenoid while rate lines is directly also connected to the interfacing unit. So that is a simple automated irrigation system, okay. So in this session we have discussed only this, and the next few topics that we will discuss in our next session, okay. Thank you very much.